Hello everyone, in this video, we shall solve exercise 2.2 of class 10 NCERT. So look at the first question in exercise 2.2. The first question is, you have to find the zeros of the following quadratic polynomial and then verify the relationship between the zeros and the coefficients. So first step, we have to find the zeros of the given question. Then after finding the zeros, we have to verify the relationship between the zeros and the coefficient. Let us do one by one. Now let's do the first question, x square minus 2x minus 8. X square minus 2x minus 8. Let us factorize this. So minus 8, if you factorize, it will come minus 4 plus 2. So when you multiply, minus 4 into 2 will give minus 8. And when you add, you get minus 2. So you will write it as x square minus 4x plus 2x minus 8. Take x commonly out, you get x minus 4. And here take 2 commonly out, you get x minus 4. Now take x minus 4 commonly out, you get x plus 2. So when will this polynomial become 0 is when the x minus 4 is 0 and x plus 2 is 0. So the x value is 4 and minus 2. So let us name alpha as 4 and beta as minus 2. So first step, we have found the zeros. Now step 2, we are going to find the relationship between the zeros and the coefficients. So we can divide the page into zeros and coefficients. So let us do some of the zeros here. Let's add the zeros. So alpha is 4, beta is minus 2. You get 2. And let's multiply. So the product of the zeros is 4 into minus 2, which is minus 8. Now we will cross-check with the coefficients. Before we cross-check, let's write the coefficients. Coefficient is, A is coefficient of x square, which is 1. B stands for coefficient of x, which is minus 2. And C stands for the constant, which is minus 8. Now let's go for the formula. So alpha plus beta formula is minus b by a. And I have derived and shown the formula in the previous video, which is equal to minus of minus 2 by 1, which is 2. Alpha beta equals c by a, which is minus 8 by 1 minus 8. Hence, it's verified that the zeros and coefficients are same in both the sides. Now let's take the second question. So the second question is 4s square minus 4s plus 1. So let us factorize this first. Four s square minus 4s plus 1. So 4 ones are 4. So 4, if you factorize, minus 2 into minus 2 will give you plus 4. And when you add both, you get minus 4. So 4s square minus 2s plus 1. You can take 2s commonly out, and that's how you get 2s minus 1. And from the third and the fourth term, take minus 1 commonly out, you get 2s minus 1. Now take 2s minus 1 commonly out, you get 2s minus 1. So when will this polynomial become 0? When you either equate 2s minus 1, 0 or 2s minus 1, 0, which will give s as 1 by 2, 1 by 2. So they are equal zeros here. So let us take one of it as alpha and the other one as beta. And once again, let's start doing the verification. So first, let's start the verification with the zeros. So alpha plus beta is nothing but half plus half, which is equal to 1. Alpha beta is half into half. 1 into 1, 1, 2 into 2, 4. And in the side, let us check the coefficients. So before we check the coefficients, first let's write what is A, B, C values. So A is coefficient of s square, which is 4. B is coefficient of s, which is minus 4. And C is the constant, which is 1. And now let's use the formula for the coefficients. So alpha plus beta is minus b by a, which is minus of minus 4 by 4. equals 1. Alpha beta formula is C by A, which is equal to 1 by 4. Hence, we have verified. Hence, verified. Next question. Question number 3. So, the third question is, before we, let's move on to the third question. The third question is 6x squared minus 3 minus 7x. Please note, before entering to the question, first arrange it properly. So 6x squared minus 7x minus 3. Now let's factorize minus 18. You get minus 9 plus 2. So when you multiply, you get minus 18. And when you add, you get minus 7. 6x squared minus 9x plus 2x minus 3. Now you can take 3x commonly out. So you get 2x minus 3. And take plus 1 commonly out. You get 2x minus 3. Take 2x minus 3 commonly out. You get 3x plus 1. So when you equate this to 0, you get 2x is equal to 3. Therefore, x equals 3 by 2. And when you equate 3x plus 1 to 0, 1 you shift it to the other side. So 3x is minus 1. Therefore, x is minus 1 by 3. So let us take the alpha as 3 by 2 and beta as minus 1 by 3. So let us check the zeros now. So when we check the zeros, alpha plus beta is 3 by 2 minus 1 by 3. Take the LCM. LCM is 6. 3 3s are 9 minus 1 into 2, 2. So 9 minus 2 is 7 by 6. Alpha beta is 3 by 2 into 1 by 3 minus 1 by 3. So 3 and 3 will get cancelled and you get minus 1 by 2. Let us check the same thing with the coefficients now. First, let's write what ABC value. So A is coefficient of x squared, which is 6, and B is the coefficient of x, which is minus 7. Please be careful. Don't write blindly as minus 3. It's minus 7, coefficient of x. And C is minus 3. So alpha plus beta is minus B by A, which is minus of minus 7 by 6. So 7 by 6. And alpha beta is C by A, which is minus 3 by 6 minus 1 by 2. Hence, verified. Let's take the next question. 4u squared plus 8u. You don't have the constant here, so you can't factorize, but you can take commonly out. So let's take 4u commonly out. You get u plus 2. When will this polynomial become 0? Either 4u should be equated to 0 or u plus 2 should be 0. So these are the two cases which will make it 0. 4u is 0 means u is 0 by 4, which is 0. And this one, u is minus 2. So let's take alpha as 0 and beta as minus 2. Let's start the verification now. First, let's do for zeros. Alpha plus beta equals 0 minus 2, which is minus 2. Alpha beta is 0 into minus 2, which is 0. Let's cross check it with the coefficients. We have to verify it with coefficients. So before we start, first let's write what is the A value. A is coefficient of u square, which is 4. B is coefficient of u, which is 8. And C, the constant is not there, so put 0. So alpha plus beta formula, we know it is minus B by A. So minus 8 by 4, which is minus 2. Alpha beta is C by A, which is 0 by 4, which is 0. Hence, this is verified. Let's move on to the next question. Question number 5. T squared minus 15. So this looks like a square minus b square. So you can just write it as t plus root 15 into t minus root 15. Because we know that root 15 into root 15 will give us 15, isn't it? How does it happen? Because you can write the common root and write root 15 into 15. So which is nothing but root 15 square and you get 15, okay? So t square minus 15 looks like our a square minus b square identity, which I have split it as a plus b into a minus b. So when I equate this to 0, I get the t values as minus root 15 and here it is plus root 15. So alpha you take it as minus root 15 and beta you take it as root 15. Let's check the zeros. Verifying part we'll do now. So zeros is alpha plus beta. So minus root 15 plus root 15, it will get cancelled and you get 0. Alpha beta is minus root 15 into root 15, which is minus 15. Let us verify it with the coefficients now. So as I said earlier, coefficients when you verify, first you write the ABC value. A is coefficient of t square, which is 1, B is 0, and C is minus 15. So alpha plus beta is minus B by A, which is 0 by 1, 0. Alpha beta is C by A, which is minus 15 by 1, minus 15. Hence, we have verified. Let's move on to the next question. The next question is 3x square minus x minus 4. So minus 12, if you factorize, you get minus 4 plus 3. And when you multiply, you get minus 4 into 3 as minus 12. And when you add, you get minus 1. So you can rewrite this as 3x squared. Instead of minus x, you can write minus 4x plus 3x minus 4. In the first two terms, if you take x commonly out, you get 3x minus 4. In the next term, take 1 commonly out, you get 3x minus 4. Now you take 3x minus 4 commonly out, you get x plus 1. So when will this polynomial become 0? Either both 3x minus 4 0 as well as x plus 1 0. Any of this combination we can do. So these are the two possible zeros. So 3x equals 4, x equals 4 by 3. And here it is x equals minus 1. So alpha is 4 by 3 and beta is minus 1. Now let's check the zeros. So alpha plus beta is 4 by 3 minus 1. So it is 4 minus 3 by 3, which is 1 by 3. Alpha beta is, multiply both, 4 by 3 into minus 1 will give us minus 4 by 3. Let us cross check with the coefficients. So coefficients, as I said, first let's write it so that no mistakes will happen. Coefficient of x square is 3, coefficient of x is minus 1 and constant is minus 4. Now let's move on. So alpha plus beta formula, we know it's minus b by a, which is minus of minus 1 by 3, 1 by 3. And alpha beta is c by a, which is minus 4 by 3. Hence, we have verified the result. Now, let's move on to the second Roman. Just see what's given in the second Roman. You have to find a quadratic polynomial, each with the given numbers as the sum and product of its zeros respectively. They have given, okay? Find a quadratic, you have to find a quadratic polynomial. So first of all, we have to see what is the formula for the quadratic polynomial. So what is the formula for the quadratic polynomial? It is p of x equals k times x square minus sum of zeros into x plus product of zeros. So here they have given in the first question, they have given the sum of the zeros as 1 by 4 and the product of the 0 as minus 1. So k times x square minus sum of zeros is 1 by 4 x and product of zeros is minus 1. So here, since we have denominator 4, we can take the k value as 4 and now we can multiply inside. This is just to have the answer without any fractions. So when you multiply inside, you get 4x square minus 4 will get cancelled, only x, and here 4 into minus 1 is minus 4. Next question. So second subdivision, they have given the sum of the zeros as root 2 and the product of the zeros as 1 by 3. So it is k times x square minus sum of zeros into x plus product of zeros. So here the denominator is 3, so we can take the k value as 3. So the p of x will become 3 times x square minus root 2x plus 1 by 3. This we are doing just to avoid the fractions. So multiply inside, you get 3x square minus 3 root 2x plus 3 into 1 by 3. 3 will get cancelled. You get 1. Now let's see the next question. So in the next question, they have given the sum of the zeros as 0 and the product as root 5. So we write it as k into x square minus 0x plus root 5. Since here there is no fraction, I will just assume the k as 1. So the polynomial will become x square plus root 5. If you want, you can mention minus 0x. The next question. In the next fourth subdivision, they have given the sum of the zeros as 1 and the product of the zeros as 1. So in fourth subdivision, the sum of the zeros is 1x and the product of the zeros is 1. Here also, since there is no fraction, we can assume the k value as 1. So the p of x will be x square minus 1x plus 1. Now let's move on to the fifth subdivision. So here in the fifth subdivision, they have given the sum of the zeros as minus 1 by 4 and the product of the zeros as 1 by 4. So k into x square minus sum of the zeros is minus 1 by 4 and the product of the zeros is 1 by 4. So since we have the same denominator 4, we can take the k value as 4. So you get 4 times x square minus into minus, it will become plus 1 by 4x plus 1 by 4. Now multiply the 4 inside, you get 4x square. When you multiply here, this 4 and 4 will get cancelled, you get x. And when you multiply here, this 4 and 4 will get cancelled and you get 1. So you get p of x as 4x square plus x plus 1. Let's move on to the last question. So in this question, they have given the sum of the zeros as 4 and the product of the zeros as 1. So here, k into x square minus sum of zeros is 4 and the product of the zero is 1. Since there is no fractions, like that you don't have any other number other than 1 in the denominator, we can give k value as 1. So the p of x will become x square minus 4x plus 1. Thank you, children.